What makes magic squares so unique in numbers? Have you ever wondered why magic squares capture the imagination of mathematicians and puzzle lovers alike? These fascinating grids of numbers hold a special place in the world of mathematics. Let's take a closer look at what makes them so unique. Magic squares are square grids filled with distinct numbers arranged in such a way that the sum of the numbers in every row, every column, and both main diagonals is the same. This constant sum is known as the magic constant. The balance and symmetry created by this property is truly remarkable and sets magic squares apart from ordinary number arrangements. One of the key features of magic squares is that every row, column, and diagonal adds up to the same total. This total is mathematically determined by the size of the square. For a square of size n by n filled with consecutive numbers starting from 1, the magic constant can be calculated using the formula. Magic constant equals n times n squared plus 1 divided by 2. This constraint makes constructing magic squares a challenging yet fascinating puzzle. Another unique aspect is that each number in a magic square is distinct and appears only once. This requirement adds to the complexity, as the numbers must be carefully placed to satisfy the magic sum condition. Magic squares also exhibit interesting symmetrical properties. Odd-ordered magic squares often have rotational symmetry, while even-ordered squares may show reflectional symmetry. Additionally, if you transpose a magic square, meaning you switch its rows and columns, you create another magic square with the same magic constant. This reveals a deeper structural harmony within these grids. When it comes to solutions, the smallest magic square, which is 3 by 3, has essentially one fundamental arrangement, with variations only by rotation or reflection. However, larger squares have many possible solutions. For example, there are 880 distinct 4 by 4 magic squares and over 275 million 5 by 5 magic squares. This abundance of solutions highlights rich numerical patterns and complexities hidden within these grids. Magic squares are not just a mathematical curiosity, they also hold historical and cultural significance. They have fascinated mathematicians and cultures for centuries. You can find them in ancient temples, artworks, and even in modern mathematical research. Their blend of numerical order and mystical appeal connects mathematics with art and history. Beyond their basic definition, magic squares have interesting matrix properties. Operations like adding or multiplying all numbers by a constant can produce new magic squares. Some magic squares are even classified as most perfect, meaning they satisfy even stricter conditions, such as pandiagonality, where all broken diagonals also sum to the magic constant. In the realm of number puzzles and curiosities, magic squares stand out because they combine simple arithmetic with complex arrangement challenges. They invite us to examine number relationships and symmetry, making them a captivating subject for anyone interested in the deeper meanings and patterns within numbers. Practical applications of magic squares extend to areas like cryptography, experimental design, and recreational mathematics. Their balanced properties can be used for encoding information, arranging data, or simply providing engaging mathematical puzzles. So, the next time you encounter a magic square, remember the unique qualities that make it a true gem in the world of numbers.